Hello everyone, welcome back to my YouTube channel. This is Sangeeta Bijay from Sri Venkateshwara College of Engineering from the Department of Information Science and Engineering 4th semester. Today in this video we are going to discuss about the subject analysis and design of algorithms, and our topic is brute force approaches. Brute force approaches, when in doubt, try everything. Brute force approaches are among the simplest methods in problem solving. Just try every possible option until the right one is found. While this method may seem naive, it's surprisingly effective in scenarios where the problem size is small or no smarter options exist. This presentation explores what brute force means, its strengths, weakness, and practical examples. We will also discuss when to optimize and when to switch to alternative methods for better performance. What is brute force? The exhaustive search explain. Definition. Brute force is a straightforward problem solving technique that exhaustively enumerates all candidate solutions, checking each against the problem's criteria. Key characteristic. This approach guarantees finding a solution if it exists as every possibility is considered, making it a fail-proof but often inefficient method. Brute force algorithms. A simple example, password cracking. Password cracking. One classic brute force use case is attempting a very combination of characters until the password is found. How it works. All possible passwords of certain length and character sets are generated and tested one by one, ensuring the correct password is eventually it. Drawbacks. This method is often slow and computationally intense, especially as password complexity grows exponentially with length and character variety. Advantages of brute force simplicity and guaranteed solutions. Simplicity. Brute force algorithms are easy to understand and implement, requiring minimal prior knowledge about the problem. Exhaustive search. Since every possibility is tried, it is guaranteed to find the solution if one exists. Baseline benchmark. Brute force provides a useful baseline to compare more efficient algorithms and test correctness. Disadvantages of brute force: time complexity and scalability. Time inefficiency. Brute force often requires exponential time, growing quickly with input size, making it impractical for large problems. High resource use. Storing or generating all candidate solutions can consume large amounts of memory or computation. Poor scalability. Brute force solutions rarely scale to complex real world problems due to combinatorial explosion. Case study 1. Finding the shortest path and why not to use brute force. Problem overview. Finding the shortest path between 2 points can be solved by checking all possible routes. Brute force drawbacks. Enumerating every path is computationally prohibitive as the number of routes grows exponentially in complex graphs. Better alternatives. Efficient algorithms like Dijkstra's find shortest paths much faster by strategically exploring promising routes. Case study 2. The traveling salesperson problem and when brute force might be okay. The problem: finding the shortest route that visits multiple cities exactly once and returns to the origin is notoriously difficult. The solution space grows factorially with the number of cities. When brute force is possible, for small numbers of cities, testing all permutations guarantees the optimal solution but quickly becomes impossible as city count grows. Useful for validating heuristic results on limited data sets. Optimizations and heuristics. Making brute force more practical. Pruning: remove impossible or suboptimal candidates early to reduce search space drastically. Randomization: random sampling combined with brute force to find good enough solutions faster. Heuristics: use domain knowledge or approximations to guide search without checking every possibility. Alternatives to brute force when smarter algorithms are necessary. Divide and conquer. Break problems into smaller subproblems to solve efficiently like merge sort or quicksort. Dynamic programming. Store results of overlapping subproblems to avoid redundant computations. Greedy algorithms make locally optimal choices hoping to find globally optimal solution quickly. Machine learning. Learn models from data to predict or approximate solutions efficiently. Conclusion: brute force, a last resort, but a useful tool. Understand when to use. Brute force is reliable for small or well bounded problems or when correctness is paramount. Combine with optimizations. Enhance efficiency using pruning heuristics or partial search techniques. Know the alternatives. Smart algorithms can often outperform brute force on complex problems, saving time and resources. In a sense, brute force is the try everything approach, simple, exhaustive, and sometimes impractical, yet an essential concept in computational problem solving. Thank you for watching. Please do like, share, and subscribe to my YouTube channel.